Hello, testing. What's up? Hey, Yosuke, hello. Yosuke says, hi, Chet. Hello, how you doing? Good morning. Or afternoon, evening, wherever you are. I am trying more Leetcode in Python today. This is the third day of doing so. Also, by the way, I just got a dental surgery. There's stitches in my mouth, so I am in slight pain right now. But I think I can still do this. Yosuke says, lol, I kinda make a edit sorta like your VTuber character. Oh, no way. Another... Yeah, it's morning for me. Official boy Sotaru. Am I back? Well, I'm not streaming every day still. Ooh, which one is it? He posted a lot. There's that one that did really well. Nice, I like it. I'll have to sign in. Whoop. I'll like it after the stream then. Man, I don't understand how you say my edits are good. Yours aren't. Your edits are like so full of effects and very dense too. Alright, let's start on this. Maximum subarray. Given an integer array nums, find the subarray with the largest sum and return its sum. Okay, I think we peeked at this last time. The algorithm is you go from start to end. Apparently there's this really greedy algorithm that you can use. You go from start to end, track a current sum. Yeah? And if the current sum goes to the negatives, then you throw everything away and reset your sum and start counting at the current one. Yeah, that's essentially the algorithm, right? Keep dropping your sum if it goes to the negative, and then keep counting your sum and tracking the maximum. Yeah, that sounds like a plan. Yosuke says, I try to make edits look like a professional, but no good. I don't know, it looks pretty professional to me. I really like the effects that you use. I have no idea where you get them. So how are you? I'm doing good. Like I said, I just got a dental surgery, so a bit swollen, some stitches in my mouth. You can probably tell the way I talk. I'm in a little bit of pain, but it's not the worst thing ever, so I'm still here. I'm still doing this. Okay, yeah, let's go from start to end. Drop our sum if it goes to the negative, and then track our largest sum. Yeah, because for example, if we go from here, it goes to -2, right? There's no way we're including any chunk of this in our largest sum subarray, or like -3 even. So we just start here. Yosuke says, you should not talk much then if you went for a dentist or your teeth with. Run away. I think it's fine. I was actually still able to talk okay yesterday when I first got the surgery, so I think for now it's fine. Yeah. Okay, let's start with this. So we need to track our current sum, right? Let's do current sum is equal to 0, I suppose. Max sum is equal to 0. Is the sum guaranteed to be greater than 0? With the largest sum and return its sum. Well, yeah, what if it's all negative? If it's all negative, then the subarray of the largest sum would be the least number, right? If it's like -1, -2, -3, -4, then the largest sum would be -1, probably. Huh. Marissa says, hello, Chet. Oh, hey, Marissa, how you doing? Okay, so current strategy, we go from start to end in the list. How do you do this in Python? Unfortunately, I have to go help family. Oh, that's okay. Good luck doing that. Okay, how do for each loops work in Python again? For num in nums, we added to the current sum, right? Current sum plus equals the current number. Yeah. Bye, Chet. Have fun live. Thank you. Good luck with helping your family. Okay, and should we do a sanity check now? I realize I have to log in too. Print the current sum, and then we'll return a bogus value at the end called, I don't know, return -1. Give me a moment while I log in. Hopefully save my progress. I think it does. Cool, we back. Now we can run this and see if we're actually printing out stuff, because I'm still unconfident in Python. -1. Okay, -2, 1. Wait, -2, -1, -4, 4. Yeah, that adds up. Rip to Leetcode. It's okay, it's back now. Okay, and whenever our current sum goes below negative, we reset it. So if the current underscore sum is less than 0, then current sum is equal to 0. That means we're dropping all the numbers to our left. And then we return current sum, perhaps. I think we should update our max sum over here. Max sum is equal to the max of the current max sum and the current sum. I think we need to put it before we reset everything to 0, because if everything is negative, let's say -1 is the biggest number, then our subarray with the largest sum is just -1. Jalson says, yo, code in CPP, who the F uses Python? Wait, what are you talking about? Everyone uses Python for leak coding. Oh, C++. I feel like Python is, I read comments like this before too. I feel like Python is really good for leak coding, is it not? That's what I hear from everyone. Like, you can get a lot done with very few lines of code. C++ is really fast, so there's merit to using that too, but I feel like Python is really efficient for typing. Okay, cool. We got case 2, case 3 working. That's a good sign. It literally just adds everything, huh? That makes sense. 1 is just 1, yeah. Chat learning how to speak to snakes. Expected is 6. We did get 6 here, actually. Why did we not update to it? Max is equal to... Well, yeah, why did I output 5 when I had 6 here? If current sum is less than 0, wait, why did this not happen? Max sum is equal to max of the current max sum and the current sum. So I outputted 5, expected 6. But the weird thing is I was printing out 6 over here. So why did this not update to 6? So for sure, it got up to 6 over here, current sum. Max sum is equal to max sum or current sum. Am I using max wrong in Python? Python, max of 2 numbers. Yeah, you just use the max function, right? Poki Kikuto says, hi. Hello, what's up? I'm Leetcoding right now. I'm Leetcoding in Python for the 3rd day, and I really suck at Python, but I'll try my best. This is really weird. So for sure, it printed out 6 over here. Wait, am I tripping? Am I printing out the wrong thing? Do some string template printout. Max sum is equal to the current max sum underscore current sum. Let's run this. Is it actually printing out over here? Chet. Huh. Am I not doing string templates correctly? Oh well, I'll just print it out regularly then. I'll also print out something here. Current sum is less than 0. Print resetted count. Oh, I'm dumb. I know it's wrong. We're returning the current sum. We're supposed to be returning the max sum. Dang it. Because current sum is always changing. Yeah, there we go. 1, 2, 3 now work. Very nice. Submit. Wrong answer. -1, 0. Okay. It's okay. We're really close though. 195 out of 210 test cases. Use the test case. Okay. Let's print out stuff again. Print. Let's print out the current sum. Max sum is equal to max sum underscore or current sum. Oh, I see. So the max number will never be, the max sum will never go below 0 because the max over here will always kick out negative numbers and pick 0. So I think we need to turn our max sum into negative infinity. How does negative infinity work in Python? Python, negative infinity. I think I should memorize this. Float, negative infinity. Okay. Max sum is equal to float, negative infinity. That's what it says, right? Negative infinity. Okay. Run. Very cool. Submit. Let's go. It worked. Okay, I'll just get rid of the print statement so it runs faster. Nice, we're 72 percentile. Circuit breaker would say this is slow, but hey, I'm satisfied. As long as we're in the majority, I'm happy. Okay, I think I should write this down. Float negative infinity, yeah. Okay. Yeah, so in Java, it's math.min integer or min double, something like that. But in Python, it's just float negative infinity or infinity. Cool. I wonder what, I want to see other people's solutions. Let's see 1.97 percentile. Oh, I see. Max sum, they just set it to negative 10,000. Current sum is 0. This is basically what I did, right? For I in nums, current sum plus equals I. Yeah. If the current sum is greater than the max sum, yeah, update the max sum. If the current sum is less than 0, reset it to 0, return the max. That's exactly what I did. Except I did a negative infinity. Why did they do a 10,000, negative 10,000 here? Was that a constraint here? Nums is, yeah. So every single number is guaranteed to be greater than 10 to the fourth, negative. Okay, cool. Next problem, maximum subarray, maximum product subarray. Okay, open link in new tab. Oh, interesting. Apparently I never solved this. Maximum product subarray. Given an integer array nums, find a subarray that has the largest product and return the product. The test cases are generated so that the answer will fit in a 32-bit integer. Okay. Chet, did you know that you can learn Python in Minecraft Education Edition 2? Well, you can. Minecraft Education Edition. Minecraft Education Edition, Python. What is this? Oh. Start coding Python and Minecraft with Leetcode. Huh. Wait, this looks really interesting, actually. Is this all in the browser, or do I have to actually download Minecraft for this? Lesson number 1. Oh. Intermediate. Understand what a computer language is. Oh yeah, I have to download Minecraft, I think. Open in Minecraft. Huh. Oh, this could be a future stream idea, actually. I like this. I'm gonna screenshot this. You have to download, I think. I'm not 100% sure. Huh. Yeah, it does look... It looks pretty interesting. I just screenshotted it. I will save it to my desktop. Minecraft Python. Yeah, maybe actual future stream idea. Okay, this looks really similar to our previous problem. I don't think the solution, I remember doing this in the past. I don't think the solution is the same as the previous problem though. 2, 3, negative 2, 4. There's a specific trick to this, right? One of those either you know it or you don't know it. And you have to brute force. 2, 3 has the largest product 6. 2, 3, negative 2. Yeah. I guess from what I can see, 2 times 3, 6. 6 times negative 2 is negative 12. Yeah, everything is just negative now, huh? But then what if we have another negative? Ooh, that's tricky. Okay. Ooh, this is tricky. So it looks really simple, right? Like 2 times 3 is 6, negative 12. So obviously we dropped this part. But then it's like, okay, what if we have a negative 1 here? And then a 2. That means we could actually use all of this. 12, negative 48, 48 times 2. Oh. Wait, that's tricky. Ooh. Excuse me. Ooh, wait. That's tricky. Can I have a hint? Chat, it looks really simple, right? Me, huh? Wait, I'm actually stumped right now, because we can't do we can't do the same strategy as the previous problem. Man, these negatives, what to do about them? So currently my best solution is to brute force. Largest product and return the product. Apparently I've never solved this in the past too. Look, I attempted this, but I never solved it. That doesn't bode well for me. Is it time to take a peek at the solutions? Right off the top of my head, I see only brute force, and our previous strategy doesn't work here. And apparently I never solved this in the past, even though it's a medium problem. Oh wait, it's a medium problem. I thought it was an easy problem. Okay, I think it's worth taking a peek at this. Anybody have a Python solution? They're using dynamic programming. Okay. Python. What's the strategy here? Think about the max product subarray as a product that will come from either direction. So we calculate from both left to right prefix, right to left postfix. Use two variables to track the prefix and postfix products. Reset them to 1 whenever a 0 is encountered. Keep track of the maximum product as we traverse. Okay, so that's kind of like the previous problem. We reset to 1, or we kind of reset the sum whenever a negative was encountered, huh? And then 0 just destroys your entire multiplication. Okay, pre, post, and answer is equal to 1, 1, float, negative infinity, and it's equal to length nums for I in range n. Pre is equal to 1 if pre is equal to 0, else pre times nums I, okay. And then the post, if post is equal to 0, 1 if post is equal to 0, else post times equal n minus 1 minus I. Oh, you're going from the end. Oh, interesting. That's a clever strategy for iterating from start to end at the same time. The answer is equal to the max of the pre, comma, post, comma, answer. Huh. Okay. This isn't a very intuitive solution. Like, I wouldn't have thought of this, but I can see why it would work. Okay, so you start from the start to end, and then every time your product goes to 0, you reset it to 1. And same from the end to the start. Chat.exe has stopped working. I know. And then your answer is the greatest from, I guess, either the max of either product from either direction. Huh. How did I think of this? I would never have thought of this. Also, I don't know. I feel like this is one of those solutions where it makes sense when you read it, but you're like, wait, wouldn't there be a lot of cases that fail this? You know? Like, what if the solution is like in the middle somewhere? Wait, that's a good question. What if the solution is the middle somewhere? What would that even look like? Let's say I have like, I don't know, 1, 2, 100, 2, 1. Maybe this is a -2. Maybe this is a -2. Oh wait, then that solution is just everything. Huh. Okay. Is it even possible for the solution to be in the middle? Huh. What if it's 0 and then 0? Yeah. Okay, and then from either direction, you would reset the product to 1 when it comes to here, and then 100 will be your solution. Okay, so it works. Cool. Okay, I've proven myself wrong. Okay, let's start on this then. So, yeah, okay, so prefix sum, comma, post, suffix sum is equal to 1, comma, 1, and then our result is equal to 0, I guess. Okay, and then we go from start to end. Should I do the way that they did it? They literally did one loop and then process both start to end at the same time. That was really clever. Okay, fine, I'll do it. For I in range len nums, okay, so prefix sum times equals current nums I, and then we do the same for postfix sum or suffix sum times equals num. Okay, so we have to start from the end. So len nums, but in programming, they start counting from 0, so everything is -1. -1 minus the I. Okay, that should go from end to start now. Okay, and if either of these are 0, then you reset them to 1, because that means you had a 0 somewhere, you multiply by 0, everything will now be 0 forever. So if prefix underscore sum, I probably don't need parentheses, huh? If prefix underscore sum is equal to 0, then prefix underscore sum is equal to 0, no, it's equal to 1. And we do the exact same thing for the suffix sum. Yeah, okay. Should we should update the maxes here, right? Result is equal to max of the current result and the prefix sum, comma, suffix sum. I realize I named these really horribly. It's not sum, it's product, right? Product, prefix product, 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 suffix product, product, product. Yeah, okay. And then in the end, we return result. Yeah. I have a suspicion that it's not going to work the first try, like something has gone wrong. So I'll print out my prefix and suffix sums or products in order to debug. Prefix, product. And then I'll do this for the suffix product as well. Hopefully it makes our life easier for debugging. Bam. Okay, let's run this. Runtime error. Nums is plural. Prefix sum is not defined. I forgot to update this when I renamed the variable. Wow. They just accepted it. Let's submit this thing. Okay, nice. Output is 0, expected -2. Okay. Oh, I know. This needs to be what we learned last time, which is float -infinity. Yay, I remembered. Use this test case and run it. Oh, it's -infinity because we're finding the max. Yay. Time exceeded. Okay, that's fine. We just have to get rid of all these print statements, I suppose, because they add a lot of latency. We did it, boys. Let's go. Hey. Cool. I'm going to note this problem down for review in the future, because apparently I never solved it before this stream. So 152. That's a really interesting algorithm. It's not very intuitive, but I guess you can see why it would work, though it does seem a bit too simple at first glance. Actually, even now it does seem a bit too simple to me. Like, why does this work? Yeah, go from start to end and back to front. Find your products, reset them if they get to 0, and find the max. Yeah. Very interesting. Next up is find minimum in rotated sorted array. What is this one? By the way, it's getting so hot in my room right now. Let me take off a layer. Oh. Okay, find minimum in rotated sorted array. This is a medium problem too. Suppose an array of length n is sorted in ascending order. Oh, hello. Bal Mukund Thucker. Oh, hi, hello. How you doing? Should we make a note channel in the Discord so one of the mods can put the notes you say into it? Oh, that's a good idea. I'm down to share my notes with people. So one of the mods can put the notes you say into it. I like that idea, actually. I can probably write my notes into it myself. I don't want to put too much work on the mods, including you, Marissa. Yeah, I'm down to share my notes. I feel like it'll be useful. In case I ever lose my notes too, I can just refer to it. Suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, the array nums, this might become this or that. Notice that rotating an array one time results in array a n-1. Yeah. Given the sorted rotated array nums of unique elements, return the minimum element of this array. Ooh, you must write an algorithm that runs in log n time. Oh, this looks hard. Apparently I solved this a long time ago. Okay, how do we do this? This is definitely some sort of binary search algorithm, isn't it? Oh my goodness. Ho, 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 ho. Oh, how do we do this? Okay, we have a rotated array here. How do we implement a binary search for this? Okay, let's say our pointer is like here, yeah? We're pointing to a 4 and then a 2. Let me make this bigger too. How in the world does this work? I mean, yeah, what do I even learn if I start the left pointer here and the right pointer here? Let's do an L here and then R. So my right is currently less than my left, which is not what you see in ascending order. So that would mean my max is somewhere here, or my min is somewhere here. Huh. Yeah. Notes exist now in hashtag other. Oh, thank you. Yeah, I can fill in my notes there. Okay, so what happens if my right is less than my left? That means, that means my left. That means the minimum is between these two, right? So in the second pass, I would probably find the midpoint, like here, move the left here, keep the right here. The right is still less than the left, so I would find the midpoint still. Like, I don't know, maybe here? R. Okay. So now 1 is now less than 2. So now we're in the ascending part of the sequence. Huh. What in the world? We're in the ascending order. We're in the ascending section of the sequence now. So that would mean... What would that mean? That would mean my minimum is to my left now, is it not? That kind of breaks the binary search. How do I handle this? Wait, so 0, 1, 2, 3, 3, 4, 5, 6, 9 divided by 2 is 4, 0, 1, 2, 3, 4. I mean, we would end up over here. Ooh. This is really tricky, huh? This binary search is really wonky. Huh. Ooh. Ball McCuntucker says, you were a kind teacher. Velveteen says, hey, Chet might not be here for the whole stream, but I pop in. Oh, hello. Hi, Velveteen. How you doing? I'm currently struggling on this medium problem. We're currently trying to find the minimum of this rotated sort array. Obviously, it's some sort of binary search, but implementing the binary search with the rotated array is really tricky. We're trying to find the minimum, huh? Left, right starts here. Okay, that's definitely the right move to begin with. So we're like, okay, 2 is less than 4. So that means our minimum is between here somewhere. So we move our right inwards, I guess. 7 is still definitely less than 2. I mean, 2 is less than 7, so our min is still definitely somewhere in here. LR. 7, 2. Do we have a hint here? Hint number 1. Array was originally in ascending order. Now that the array is rotated, there would be a point in the array where there's a small deflection from the increasing sequence. Yep, I'm aware of that. You can divide the search space into 2 and see which direction to go. Can you think of an algorithm which is O log n search complexity? Yeah, I can divide the section into 2. One is the ascending portion here, and the other is the smaller ascending portion here. Huh. Hint number 3 is All the elements to the left of the inflection point are greater than the first element in the array. Yeah. All the elements to the right of the inflection point are less than the first element of the array. Uh-huh. Huh. Is the trick to find the inflection point then? I'm 7, but I'm watching this. Code with Ven. Ooh, Code with Ven. Hello. I'm currently on Leetcode 153, and I'm struggling like heck. Okay. Are we doing something wrong here? Okay, so if the number to the right is less than the number to the left, that means the inflection point is somewhere in the middle, is it not? Okay, what do we reduce though? Is the left? The inflection point is in the middle somewhere here. Do we cut our left like here? And then right like here? And then the right is still less than the left, so that means the inflection point is still in the middle here somewhere. 7 and 2. I feel like I'm doing what I just did before though. So I'd cut it more here, and then R. Wait, but at this point, I would know that I'm in the ascending portion because 1 is less than 2. We're definitely in the smaller ascending portion now. Does that mean we just go to the left then? Like this way? Until we find the minimum? I think that's my strategy. Huh. Yeah, I think that's my algorithm. So while the right is less than the left, we keep shrinking our left. Okay. And then until we get to the point where we're in the smaller ascending sequence, like the left is less than the right, we just keep going right until we hit the minimum. Yeah. Is that not the algorithm? That's my idea right now. That should be roughly log n time. Unless like, I don't know. I'm trying to think of some like really weird edge cases. What if it's like 1, 2, 3, 4, 5? We don't need to even narrow down the smaller ascending portion, like left. I mean, the left is already smaller than the right, so we would keep going left until we can't anymore. And 1 would be our solution. Yeah, so I think that's our algorithm. It's not. So while the right is smaller than the left, we keep closing our left in. And then by the time the left is smaller than the right, that means we're on the ascending smaller chunk. And then we keep going left until we can't anymore. And that's our minimum. That's what I'm thinking. That should be roughly log of n time. Okay, I'm really unsure about the solution though, so I want to check on some answers. Okay, here. Oh, approach. Our correct answer is the right side of the array is in the right side of the array, the smallest element. In order to find it, we are going to use binary search. Okay. Dang, this is just like 3 lines of code. Okay, LMR, okay. M should be in the right part of the array because what? Let me make this smaller so I can fit it in. M should be in the right part of the array because the smallest element is there, and we can move pointers LMR according to look at what is this guy writing? Where is M? If M is in the right part of the array, we are in the correct side. We should decrease M to find the min number. If M is in the left side of the array, wait, what is this guy talking about? Our correct answer is in the right side of the array, the smallest element. Oh, like he's splitting into halves here. Okay. if m is in the right part of the array, so meaning this chunk, we're in the correct side and we should decrease the m to find the min number. If m is in the left side of the array, we're in the wrong part of the array, and in order to change it, we have to increase m. Okay, so if the left is less than m and r is less than nums m. Left is less than m, right is less than m. Okay, so that means m is in the left side that he's proposing. Then L is equal to m plus 1. All right, I think that makes sense. Else, if m is in the right side of the array, we need to reduce m, so r minus m minus 1. Okay. While L is less than R, M is equal to, yes, M is the bisection. If M is on the right side, then M plus 1, else M minus 1. Result is equal to the min of result, comma, nums M. Return result. Okay. I guess that makes sense. Let's try this then. I think I was confusing myself because I didn't even include an M here. Okay, I mean, if you include an M here, I guess it's more simple to think about. So if M is greater than L, and also greater than R, then that means it's on the right side. But we want to be on this side, right? So we will put our L somewhere here. And R. Yeah, and then else, that means we're on this side, and we should decrease our M. All right. Wait, when do we update our M though? Result is equal to min. I guess we're constantly taking the min. Okay. And then over here, M would be here. My brain, it hurts. And we can see that it's on this side now, so we can just minus it. R is equal to M minus 1. Yeah. And at that point, R and L are the same, so we exit. Okay. I think I have an idea how to do this then. Okay. So we have our L, comma, R is equal to 0 and nums, the length of nums minus 1. So L and R start from the start and then the end. Okay, so the first case is M is on the left side, this side. M is on left side. Oh, also we have to do while L is less than R. So that's our stop condition. Well, m is on the left side, so we can see here, how do we know if m is on the left side? If nums L is less than m, or nums m, and this is plural, and nums m here is greater than the right number, is greater than nums r, then we are on this ascending left side. And we know for sure that our answer is on the right side here. So L is equal to m plus 1. L is equal to m plus 1. That's an if statement. And else, that means we are on the right side, I guess. M is on the right side. Velveteen says, how did I just realize that those arrays in the problems were relay rotations of the first one? I thought they were all just random arrays and just saying were rotated a certain amount of times. Oh yeah, it is confusing. Yeah, rotate array sucks, man. My brain turns off the second I look at a Leetcode problem, I swear. Yeah, same. Leetcode problems sometimes are pain. Okay, if m is on the right side, then that means r is equal to m minus 1. I mean, yeah, what happens if m is like here? You know? Maybe our L is like here. My brain turns off the moment I see anything related to coding. Huh. Wait, actually, this part doesn't make sense to me. If m is like here, we still want our L to close in on here, right? What in the world? R is equal to m minus 1. M is on the left side now. Wait, this else condition doesn't make sense to me. So we're saying R has to be here now. What? That doesn't make sense to me. Or is it even possible for us to get to this point? If m is on the right side, Chet, I just noticed your background music is turned off. Oh, thanks for reminding me. Thank you. Less than nums. Right, m is equal to, I forgot to do that part. L plus R divided by 2. Okay. I'm just gonna roll with this for now then. Result is equal to float negative infinity or infinity. And then we're constantly taking the minimum. Result is equal to the minimum of the current result and the current nums m. And then we return result. Okay, let's run this. Wrong answer. Output is 1, expected 0. Expected 11. We're constantly 1 off. Velveteen says, wouldn't sorting an array always have the same result? So as long as it's the same numbers, or am I missing something here? Oh, sorting an array is n log n time. Code with Venn says, less than equal. L is less than equal. Does that actually help? Wow. Wait, why? I don't understand why it works. Well, thanks, Code with Venn. Can we run through an example? Like, why is this needed? Alright, boys. So we start left here, and then right here. 0, 1, 2, 3. 3 divided by 2 is 1, so L gets moved. Well, the midpoint is here. Consider an example with just a single number. Oh, with a single number, huh? Just 11 then. Oh. So it wouldn't even enter the loop to update any number from here. So, okay, L is 0, R is equal to 0. So we just return the result immediately. And our result is infinity Yeah, we wouldn't even enter the loop, huh? And for the case of here, what will we do here? So LR, we're on the so-called right side, so R is equal to n minus 1, 0, 1, 2, 3. 3 divided by 2 is 1, 0, 1. Is L less than nums? So R is equal to n minus 1, which is here. So L and R are the same thing here. No, it didn't work. Output is 2, expected 1. Ooh. Scientific cryptid. I see. In your previous implementation, it wouldn't have entered the loop, but L less than equal to R will. I see. Okay, what about this one? Let's use this test case. 2, 1. Okay. Should we just print out what L and R is? I think that would be helpful for debugging. Print L, and then print what R is, R, and then we print what M is as well. Okay, I feel like this would be helpful. Okay. So 0 is... So L and R start off as 0 and 1. and then m is 0. And then we immediately exit. Oh my goodness, fantastic. Why do we immediately exit though? L is equal to m plus 1. Is that what we do? If nums L is less than or equal to m, wait, print, move right, and then print, move left. Run. We move left. That's the wrong move. Oh, I see. So this is a case where the midpoint is the same as the current thing. Equals. Yeah, I see your suggestion code with Venn. Thanks. So that's what this is for. This is for if the midpoint is the exact same number as the left. Okay. And then the midpoint is also both the midpoint and the left are greater than r, which is this case. So the minimum portion is still on the right side, so we still want to move right. I see. All right. Wow. We did it, boys. All right. Cool. Let me submit again to get a better score after removing all the prints. And whoa, we got 100%. Okay, I'm definitely noting down this problem for review. 153, huh? 153. Okay. Okay. Man, this solution is still like really unintuitive for me. I want to try running through an example another time. Let's do maybe... Let's do this one. I want to run through another example. I feel like it would give me a better idea. Okay, so left is here, right? And R is here. 0, 1, 2, 3, 4. 4 divided by 2 is 2. 0, 1, 2. So our midpoint is over here. And we're like, okay, clearly the left and the midpoint are on, you know, the right bigger chunk. So we want to move everything to the right over here. So we're like, okay, we move our left here now. So L is now equal to m plus 1 here, and R, and then we're like, okay, clearly M is on, L and M are like the same space now. M is on the right side. So that means we move R to the here. L and R are the same thing now. Yeah. And then we converge on 1. All right. Marissa says, Chet, I have to go now because I need to go to a place called bed. Oh yeah, I have to leave soon too, actually. All right. Thank you to everyone for coming then. Yeah, I was about to leave after this problem too. So, thanks Code with Venn. Thanks Scientific Cryptid. Thanks Velveteen. Thanks Marissa. We did 3 problems today. That's pretty nice. All right, bye guys. See you next time. Bye. Thanks Scientific Cryptid. Bye Velveteen.